Good morning, everybody. My name is Carl Walter. I'm the National Security Industry Manager here at Esri, and I'll be facilitating our webinar today. Our webinar is titled Leveraging ArcGIS in the Counter-Drug Environment, and our discussion will focus on managing the opioid epidemic. We are scheduled for a full 60 minutes, which should include plenty of time for a few questions, and you can submit those questions through the online webinar tool. If we are unable to get to your question for some reason, we will respond to you directly through the email address that you provided us when you registered. If you are interested in more specific information on what you have seen today or how to deploy the Esri platform, there'll also be an option for you to request specific follow-up information, and we'll be sure to have the proper Esri personnel reconnect with you to answer any of those questions. Our agenda today is quite simple. I'm going to introduce our team of presenters, and they will go through a series of workflows that will depict several use cases. So we're going to focus on first prevention, then intervention, then enforcement. So on the supply side of the conversation, obviously our workflows will be enforcement based, and then on the demand side we'll be showing you different capabilities, tools, techniques on prevention and intervention. So why are we all here today? If you can just see on the side of my slides here, the amount of destruction that that heroin, that opioids are doing to our communities, and you just have a couple examples that I found really quick and easily by just going online and searching on 46 fatal overdoses in a weekend in Cleveland Metro. 51 ODs in Northern Kentucky, 151 ODs in 4 days in Louisville. So, our hope is, and part of our objective today is to help give you folks some ideas on how to get in front of this epidemic. It is everywhere, and it's killing, according to the CDC, up to 91 Americans every day. It is the leading cause of death today, and the rate of prescription writing is only going up. And again, for the guys, the boots on the ground, the first responders in the street, things are at a breaking point. So introducing our team today, Kevin Armstrong will be helping out with our presentation. Kevin's a public safety solutions engineer. Also a public safety solutions engineer on our patterns and practice team is John Petter. Rob Fairstein from our national security team, and Lindsay Hayes. Lindsay actually works for our professional services division, and she's a technical consultant on site 4 days a week at the U.S. Postal Inspection Service. So in addition to the prevention intervention enforcement concepts that we're going to be discussing, we'll also see and discuss common analytical workflows of collection, analysis, and dissemination, and how this GIS, how the Esri platform supports various operational workflows. So I'm going to begin the conversation focused on a prevention conversation and some tools to support different prevention workflows. It'll be about ideas on stopping or slowing down, reducing the opioid problem and the effects that it has on all of our communities, white, black, rich, poor. And the idea here is education and training, how a community can provide education and training to opioid users, their families, community partners, as well as some other interesting capabilities of how to report anonymous drug activity. Kevin Armstrong will be focusing on some intervention workflows. He'll be discussing and demonstrating mobile field collection capabilities, real-time reporting, how to collect overdose information in the field, how first responders can do that, submit that data to a central repository, link that information to an operations dashboard for alerting through GeoEvent extension. And when I say intervention, it is short of enforcement. It's a specific action like these OD collection tools meant to intervene, but short of enforcement. Rob Fairstein will talk about two different things. The first time he comes on, it'll be intervention methods. He'll actually do some incident analysis various incident analysis workflows, identifying different problem areas with drug data and crime data. The data that we're going to be using is actually real data that we grabbed from the City of Boston Open Data Portal, and then later on in the conversation, he'll be doing some enforcement workflows, operational planning to support a search and raid operation or surveillance operation. Lindsay Hayes is going to strictly focus on enforcement workflows, and she's going to talk a little bit about efforts at the U.S. Postal Inspection Service and how she supports those guys. And John Petter will then get up again with enforcement workflows and talk about drone to map. So John will be actually show you some field collection capabilities, how to grab real-time, near real-time imagery and use that to help support what Rob's actually going to do, which is showing the operational workflows. So first, I will start off going into a story map. And the idea of this story map is something that a community, that a government can create for its community, whether it's public health officials, public safety agencies, a mechanism to communicate what is happening with heroin, with drugs, with opioid addictions in their community. And I'm just going to go through a couple examples of some ideas of how a local, state, a government entity can deploy these tools to inform and educate the community. This example right here is a very simple link to CDC showing overdose deaths 2000 to 2015. I'll page down here and show some examples of open source story maps that people have created over the years. This one's called Share Your Story. I'm going to hit that hyperlink and go into an example real quickly here of how the community can go in and add information about a lost loved one, and that information can be shared with whoever is interested in looking at this type of information. So again, very, very interesting example of how people could tell their story. Information on mortality rates. In 2016, individuals over the age of 25, opioid deaths under the age of 25, also in 2016. Not everybody dies when it comes to these scenarios, and we've got an example with just male overdoses in 2016, female overdoses in 2017. The use of Narcan on a swipe map. So you have an example for 2015. Slide that over and see what it looks like in 2016. You can see the significant increases on Narcan saves. And an idea on how the community can submit anonymous drug activity to the police through a quick and simple form that you can fill out in about 30 seconds, identify the location of the activity and submit that. Some web maps and some web apps on how to locate treatment facilities. I'll click into that real quickly and show you how it works. Again, with the idea of deploying this type of technology to the community. I'll type in an address here real quickly. And then we see the locations of drug treatment centers, public health and human services, hospitals and clinics. And then we can actually click on and zoom in the location of where those are. A similar workflow for drug drop-off locations. And that works the exact same way. I'll type in the same address. And again, you can see the locations of where to drop off unused prescription medications. Again, when we're talking about prevention, intervention, enforcement, on the demand side, we want to focus on prevention, and this is just some really basic ideas of story maps and web apps and web maps that you can deploy to the public to help educate them, to help inform them of what's going on there in their community, and then ways that they can help. I'm now going to turn this over to Kevin Armstrong, and he's going to go through some mobile collection examples, real-time reporting, and then some analytics and insights on how you can actually slice and dice that information up. So I'll turn it over to Kevin.
All right, thanks, Carl. Let me know if you can see my screen.
Yes.
Okay. What I'd like to walk you through is an example of a workflow that is currently being used by the Washington-Baltimore HIDA. The apps are slightly different, but the information flow and the analysis is the same. And what this is a way to, as Carl mentioned earlier, we've seen a lot of different cities that have large spikes in overdoses in a weekend, like Cleveland and Cincinnati, et cetera. Some of those he talked about where they're seeing 50, 60, even more overdoses in a weekend, and it's difficult to get out in front of a problem like that. Usually it's by the time the dots are connected, it's too late. Well, to answer that sort of problem and help not only law enforcement but public health officials get ahead of the trend of these large overdoses in a short amount of time, we've developed a very simple out-of-the-box application. Right here is a web-based mobile data collection form. This is the GeoForm app that Esri builds, and this requires no customization. It's an out-of-the-box app and takes just a few minutes to put together. And what this app does is allows first responders, whether that be police, fire, EMS in the field, to enter the location of an overdose. So when I load up this form, it automatically grabs the date and time, and I can enter some very simple information about the overdose that I'm collecting information on. What is the status of that overdose? So is it fatal, non-fatal? Maybe the subject's final outcome is unknown, so we can select that as well. So in this case, I can just say non-fatal. Were they given naloxone or Narcan, as we commonly know it? I can enter the number of doses that were given to them. And the next thing I can do is select a location. So I can either type in an address, or it will use the GPS location from my smartphone to locate me on the map. So what I'll just do is I'll zoom out a bit here and show you. So it has my current location. In this case, I'm actually going to pan over and enter a location over by the Carolina Place Mall here in Charlotte. So I'll just tap on the map, so I can obviously move the map or move the dot around depending on where I am if my GPS isn't good. And once I'm done that, I can submit the overdose. So it says, okay, my overdose has been submitted. Now, back in the office, what we see is that overdose, this is our operations dashboard, showed up on the dashboard almost immediately. And what happens behind the scenes is our GeoEvent server is polling these inputs. As this data is coming in, I'm getting a live feed of it from the field, and we're buffering that input. So once an input comes in, have there been 5 or more overdoses within a certain distance of that location in the last 4 days, then it will generate a hotspot. And that's what it's done behind the scenes. That's why this buffer has turned red. It's telling me that, hey, there's an alert. There's an outbreak of overdoses within this area of Charlotte. And this dashboard is something you can put in the hands of an analyst or have in a watch center or somewhere that can be constantly monitored. So I can see the location of the last overdose that was just entered at 12:03 p.m. I can click on the map and it will highlight that particular location. I also get some summary statistics about this, so I can see, in the last 4 days, what are some of the trends that we've seen in the overdoses? How many are fatal versus non-fatal? How many total reports have we received within that time frame? So it allows me to really have a real-time view of the overdoses that are going on within my jurisdiction. And on the next page, we can see overdoses by, in this case, we're doing it by county. So as the point comes in, we tag the county that it's in. But you can easily do this by a police district or something like that. And I can also see the total number of doses of Narcan that have been given out. In this case, in the last 4 days, we've administered 10 doses. And here's the hotspot that was generated. So all this goes on behind the scenes and happens automatically. Now, sometimes you may not be, watching your dashboard and able to see that an overdose is created. Maybe you're at home, maybe it's 2 in the morning, but you still want to be notified. So if I go back to my phone, we'll see here something else that also happens. In this case, the GeoEvent server, when a hotspot is detected, it draws it on the map, but it also sends out an email and or a text message reporting that there was an overdose. So no matter what, I usually have a phone near me. I may not be looking at a dashboard, but now I can send out those alerts to either one or multiple people. Maybe I have a police agency, public health officials, and they all receive these alerts to their phones telling them that there is a hotspot detected, and there have been a certain number of overdoses in the last few days. So just a very quick and easy workflow to help you get on top of the real-time notification of these outbreaks of overdoses for opioids. Now I want to switch gears a little bit and look at some ways from perhaps a treatment perspective. We've identified that our area has an opioid overdose issue. We're trying to figure out what are some of the best ways to address that. And what I'd like to do is just figure out a little bit more about where our hotspots are and what is it about those areas. What are some of the demographics or income, age breakdowns that might help me craft my response to this epidemic. So what I'm looking at here is our Insights product, and what I'm going to do is just make a simple map. I'm going to add in the locations of all the overdoses that have been entered through this mobile app. Now this is demo data, it's not real data, and I'm just going to zoom into my area of interest here around Charlotte, and I can see the overdoses that have been submitted from this app over time. And some of the very simple things I can do to begin to investigate the data is just look at the symbology. I can change the symbology and look at, outcome. So I want to see what are some of the outcomes from these overdoses. So I can just click on fatal and see where my fatal overdoses are occurring versus non-fatal. And I can see where are the ones that were unknown. Or I can look at maybe the number of naloxone or Narcan doses that are administered. So I can see, 0 to 1, 1 to 2, where am I administering a lot of naloxone. And the other thing I can do is just simply look at a heat map. Right? I want to see where are the densities of hotspots that we're seeing. What are some typical hotspot areas that I can begin to look at and investigate further. So you see here we have 4 main hotspot areas in this region. The other thing I can look at is some of the, since in this mobile app we're collecting the date and time of the overdose, I can create a pretty simple chart of how many incidents we're seeing over time. So in this case I can see where am I seeing spikes. So obviously I see that towards the end of February we had a large spike on the 28th. And if I click on that, my hotspot map will change and show me where those hotspots were on that particular day. Same thing if I go down here to the end of April and select that area, you'll see my hotspots update. So when we have these outbreaks, I can look at the historical trends and see where they're occurring over time. The other thing I can do is just look at the outcome. So am I seeing a large number of fatal versus non-fatal overdoses? I can change, I can look at that by a bar chart, column, donut chart, and easily see where are my fatal overdoses occurring, where are those hotspots. So I see I have 3 main hotspots for fatal overdoses. Versus non-fatal, you see it's really just 2 main areas where I'm seeing a lot of non-fatal. So again, very simple, easy to use tools to look at some of the trends in our overdose data. The other thing I'd like to do is actually, perhaps I want to put together, I want to filter this data. So I said this is actually, when I zoomed out before, this data spans the entire East Coast, but I'm really interested in just 3 counties. Maybe I want to form like a tri-county task force or something to address this problem. So what I want to do is just filter out the data for just those counties. So I select these 3 counties and I can say let's just filter my data. So I'm going to choose my overdoses and filter it by the counties and hit run. And so what this does is I can rename this data set. This will be my tri-county overdoses data set. So now I'm looking at just the overdoses that have occurred within those 3 counties. And I can change my symbology back to maybe just my original symbol to look at that. So the next thing I'd like to do is just a little bit of analysis on the density of these. So Insights comes with some out-of-the-box spatial analysis tools. So what I want to do is just calculate for this tri-county area the density, or where are my hotspots for overdoses, in this case the history of since I've been collecting them. So I can just run this density tool, and what this does behind the scenes is it's running a kernel density analysis of my point locations. Again, I filtered this just for the Charlotte area, and if I turn that off, we'll see now I have some hotspots for overdoses within this area. So I see I have about 6 areas here that are hotspots. And what I want to do is I want to focus on just these areas. So I can select a couple of these, just hold down Shift and select a couple of hotspots. And what I'd like to do is do an aggregation. So I want to take my hotspot areas and I want to count how many overdoses have happened in them. And if I want to, I could also sum up like the number of naloxone doses that have been administered in those areas as well. And I can run that. So what this does is it automatically shows me the count. It's symbolized my map by the count of overdoses within these areas of high density. So I can see even among the most dense areas, some have more overdoses than others. So we can rename this, call this our tri-county density. So now that I have that, and I have counts, what I'd like to do is, let me just change our symbology here. I'd like to find out in these 5 hotspot areas, what about the people that live in there? Are there any ways I can learn about who lives within that area to better tailor my treatment or intervention programs? So what I'm going to do is enrich this data. So I'm going to select the Tri-County Overdose area, and I'm going to open up our data browser. And what this does is allows me to access the demographic variables that are hosted by Esri. And there are several hundred variables you can choose from here. We have a couple of the highlights, some of the very popular ones here, or I could look at all the population variables. You can see there's just a whole host of variables you have at your fingertips. But what I'm going to do is take a few of the basic ones like total population. I can search on things like maybe age, if I want to look at Let me go back. Let me do median age. We can do that. So I'll take the 2016. Let me go 2016 median age. We can do things like income. What's our median household income? And again, I can begin going through a lot of different variables here. Things like maybe poverty. Is that related to our opioid overdoses? Or maybe I can look at diversity. What's our diversity index? How diverse are these areas? And I can also look at things like Tapestry. So I want to look at what's the dominant Tapestry segment within these hotspot areas. So once I've gone through and selected a few variables that I'd like to know about these areas, I can just hit apply and run. And what this will do is query those areas and look at those demographics within there. So if I view our data table, actually let's just expand it here. I can see I have my count of overdoses, but I've also added to these areas our total population, median age, household, everything that I selected within there. So now I can begin to look at correlations. So the count of overdoses by, say, total population. And let's make a scatter plot of that. And I can bring that over, add in a trend line here and see, are there any significant trends by population and count of overdoses? So we see it's not a very strong correlation there. But then I'm going to begin to expand my analysis and look at some of the other variables, like, say, median age. Is there a positive or negative correlation? So it's slightly negative here between the count actually goes down as the age goes up. So again, this information is going to be very different depending on your area. It's important to kind of run this analysis for your area because, as we know, opioids really don't target a specific gender or age group or income group. It's really a sort of a wide-ranging problem. But this is a very simple way to begin to explore the data for your area. And the last thing I want to do here is just look at our Tapestry segmentation. So for these 5 areas, I can create a chart. Let's just we'll do a tree map of the tapestry in these hotspot areas. So what's the dominant tapestry? So young and restless here, this area has seen the most overdoses. So within our hotspots, this area, this tapestry segment is the dominant one. So I can look that up really quickly and say Esri, tapestry, young and restless, and we can bring up the information about that specific tapestry. So I can see information about the household size, income, and all the information that might help me craft a successful intervention strategy. So some of the traits here, most of their information comes from the internet and TV rather than traditional media, as we see right here. So that helps me know that putting information in the newspaper probably isn't a good idea, or on the local news. Maybe I want to look at something more along the lines of web-based, maybe social media or something. I can look at their age and the ethnicity and the income. What are some of the occupations that this group that I want to target, what are they involved in? And I can also look at some of the market profile things, like they like watching MTV and Comedy Central, reading fashion magazines, they use Twitter and Facebook. So again, very useful information if I'm trying to target a particular group of people that are in my area are at a high risk. And of course, this is going to vary quite a bit depending on the area you're in, but that's what makes this analysis very important and very useful for your area. It helps you craft your response strategy. All right, with that, I'll finish and we'll go back to Carl.
All right, Kevin, thanks. That was great. And I think it's a good example. Let's unpack a little bit about what he just said right there over the last 10, 15 minutes. So he showed a whole bunch of sources of information, some traditional, some non-traditional, most, if not all, open source, especially on the overdose information side, in that a lot of communities now are through open data portals are sharing unbelievable amounts of data about whether it be crime or other types of data points to the public, where anybody can download some of this information and start doing great analysis. He added different components in bringing in the demographics and the Tapestry data to really analyze at many different levels what's potentially creating that problem in that community. And he did that with a bunch of different technologies, with insights, with a mobile field collection, with dashboards, and with geo event. So the overdose problems that he outlined oftentimes, unfortunately, correlate with crime problems. So Rob's going to go through some more, pre-enforcement strategies, intervention, analytics that, again, help understand the crime situation that may be, in most cases, related to the drug scenarios. And he's going to go through a bunch of incident analysis types of techniques. And Rob, I'm going to turn it over to you.
Hey, thanks, Carl. So as Carl mentioned before, today for our presentation we're using some open data. We just went to Boston's open data site, and I was able to do a quick search, and there I can find several data sets related to the crime data that they're making available to the public. So in addition to open data, we also have open solutions here at Esri. So if you go to the solutions page, and we have a gallery, and we have several solutions. I believe we're at over 500 now that can easily be downloaded and utilized with the ArcGIS platform. Today, to kind of balance what Kevin was showing with insights and going very tactical into the data and looking at the relationships between crime and incidents and the demographics, we'll also do some strategic analysis in Pro and come up with some different outputs. So we'll look for the incident analysis template. And here we can easily find it and learn more about it. So with the incident analysis template, before you get started, there's a bunch of videos and documentation to better explain what the tools do, the outputs that it creates, the data that it comes with, how to get started, what's required from your system, what versions of the software it supports. So this particular template supports both ArcMap and Pro, so 10.3.1 or later, and Pro 1.4 or later. It goes into detail over all the different workflows and the outputs that we'll see here just in a second, and additional resources if you need help and to look at the difference in the versions that have been released, or if you need to download a previous version for ArcMap. Once you've downloaded the template, you don't need to be an administrator on your system. It's just a zip file. You unzip it and open up the project template, and you can begin working in Pro. It comes with sample data sets, some incident data. I believe we put some genericized information over Monterey, California, just to kind of support the tutorial and getting to understand the tools. And for those analytical results, and we'll kind of look at these a little bit later over the city of Boston, looking at some cluster analysis. There's a tool to look at the streets and the incident data and correlating the two. Percent change by zone or administrative boundaries. The incident hotspot by area, and just the incident hotspot tool. Incident density, and as well as emerging hotspots. So we're going to take a look at a few of these today with that crime data that we were able to download from the city of Boston. So I took the what's available for 2017, about 6 months worth of data, and put that into Pro. So using the incident hotspot tool, I'm going to come over here to my project window. So once I've deployed the project template, all my toolboxes from this template are deployed. So opening those up, we have the incident hotspot tool. I'm going to take my 2017 crime data, my patrol zones for the city of Boston, and quickly run that tool. And once complete, I now have the incident hotspot for the entire city, which, you know, probably shows a lot of the major populated areas are being highlighted. This level of analysis, you know, shows the likelihood of, you know, incidents where they will occur or are least likely to occur. A more traditional data set or output is looking at the density as well, which really in this case points to downtown Boston. If I wanted to just do a quick comparison and see how that lines up to my population density, Pro is integrated with ArcGIS Online, so I can easily look up all the data layers available within ArcGIS Online and find USA population density. Bring that in and let that load. We'll zoom in a little bit. And within Pro, we have the swipe tool. We can come in here and we can use the swipe tool and look at the comparison of where that hotspot is and the population density under it. From here, using Kevin's workflow and the community analyst data will allow you to dig down and drill further into the demographic data offered by Esri. So now that we've looked at the crime data and have some general ideas of where crime's occurring in the city and have a couple different outputs, let's look at just the drug incidents. So I've taken that same data set and I've filtered out all activity related to heroin for that same time period for 2017. And so we have enough data to use the tools. With a more tactical output, the cluster analysis tool allows me to define my area of analysis. So I'll put my incidents in, that same data set from 2017. I used a 500 meter tolerance, and then I created these clusters based off of those parameters. So now I have 500 meter clusters with the count. This is a great product for briefing. It gives a quick visual aid to show you, where these incidents are occurring and how frequent. Another way to look at the data, in addition to the patrol zones, you can also take U.S. national grid. So here I took the 1,000 meter grids just over the city of Boston, and using the percent change tool, again, another tool available in the incident analysis template, I took my 2016 data from the same time period from last year, and I used the grids, and then I inserted 2017, and I ran the tool, and within a couple minutes I get an output that tells me where activity is decreased and where it's increased. I've changed the symbology. There's only one area that has an obvious increase of activity. And then using some out-of-the-box tools, spatial join, and then just coming up with the change using the field calculator there in the attribute table. I can also see within these different grids areas that have increased activity for this same time period this year compared to last year that we may want to do additional analysis or focus our interdiction operations. And so with that, I will turn it back over to Carl.
All right. Great, Rob. Thank you. So, again, the links between the drug overdose information, the heroin information, the crime information, the demographic information, bringing that all into one environment really is the key to what we're trying to do and what we're trying to show to help folks really dissect what's happening in that community, and the ability to interrelate all that data simultaneously is really quite powerful. So we talked about some prevention, some intervention, that really are helpful on the demand side. We're now going to switch this over to Lindsay Hayes, and she's going to talk a little bit more on the enforcement side and a little bit about what she is doing as an Esri Professional Services employee detailed out to the U.S. Postal Inspection Service. So Lindsay, take it away.
Great, thank you, Carl. Hi, folks. As Carl mentioned, my name is Lindsay Hayes. I'm on site with the U.S. Postal Inspection Service and the Office of the Inspector General. Those are the two law enforcement branches of the Postal Service. They investigate crimes and catch criminals who commit them through the mail. So today, unfortunately, because the data I work with is protected, I can't show you any cool maps similar to what you've seen from Kevin and Rob, but I want to talk a bit about the techniques that we have for spatially enabling data and also what we use to make our enterprise GIS successful. So first, I'd like to start out by talking about opioid parcels. Criminals frequently need to shift the locations of their opioid stock in order to make their illegal drug businesses viable. This includes moving opioids from countries with less stringent prescription drug laws to the United States, as well as transporting drugs from city to city domestically. Movement of opioids and other illicit drugs can occur via freight forwarding, cargo, maritime, human trafficking, or through global post and private couriers. The United States Postal Service is just one of the many channels through which drug traffickers move illegal goods quickly from point A to point B. The USPS ships between 1 and 3 million parcels every month. Identifying which parcels contain drugs and the traffic patterns of the drug dealers who ship them is not a small challenge. The Postal Service uses GIS to understand the flow of illegal opioids and curtail their trafficking. And I wanted to show this image here. This is a headline from the Boston Herald from about a week and a half ago. The DEA seized 50 kilos of fentanyl chemicals from a storage facility in Massachusetts. And, immediately kind of looking at this, if you have a job like mine, you start to think, it looks like some of these packages previously were shipped. They look like they went through the mail. So questions that I immediately ask are, where did these packages come from and how did they get there? Well, fortunately at the Postal Service, we can answer those questions from the data that we collect. So if I could get the next slide, I'd like to talk a little bit about package location information. Thanks. Yeah. So each package that enters the postal system has multiple locations associated with it. GPS systems throughout the Postal Service record a package's physical location with latitude and longitude values. These GPS coordinates can be brought directly into Portal for ArcGIS or ArcMap to get a better idea of where the package was at a certain time. However, most of the locational information for a package is relative information. That's recorded in the form of street addresses and zip codes. So packages typically have a return address and a destination address, which you can see in that image at the bottom there. But they also have a zip code of origin. That's a location where the package goes across the counter, where it's received by the Postal Service. Opioid packages seized in transit don't have GPS values for their final destinations, however. The address information on the parcel shows where the sender intended the package to go. And this is really where geocoding comes in, and this is an area that I want to talk about next, because this is where the post office really shines. If I could get the next slide, please. Thank you. So addresses are relative locations. They're based on the street network to which they belong. They can't be added into a map until we find the associated latitude and longitude. Geocoding is the process of associating a latitude and longitude with an address, and the USPS has some really incredible geocoding resources. The Postal Service actively maintains a GIS database of every deliverable address in the United States and its known latitude and longitude. That's over 190 million locations. We use this data in combination with Esri's core technology to create powerful address locators capable of finding the physical locations of any address in the U.S. We also use locators from Esri's Street Map Premium and the World Geocoding Service to geocode international and domestic addresses at multiple levels. And lastly here, I want to talk a bit about processing and displaying the data in an enterprise GIS, because this is really the key to making your data sources useful after you spatially enable them. So spatially enabling the address information on package data opens the door for GIS analysis. Although processing large numbers of records each month is a challenge, it's the starting point for many postal GIS workflows. After spatially enabling these large data sets, we must cut down and display the points in ways that are useful and informative to the end user. If a GIS layer is too big and clunky for its average user to analyze and query, then all the work that went into geocoding the data set will have been in vain. At USPS, we put a lot of thought into constructing web services and applications which use these large data sets effectively. By making the commitment to spatially enabling our data sets on a regular basis, we allow USPS users to start to ask spatially related questions. Things like, do zip codes which have high instances of opioid mailings have similar characteristics? Have the origins and destinations of opioid packages shifted over the years? Once these questions start being asked, we then return to the construction of the original GIS data sets and make sure that they can answer them. A really important takeaway I'd like to leave you with here is that, constructing a good GIS is a circular process. We're always finding new ways to present the data in order to better support the analysis of the end users. So that's a brief overview of the work we're doing at USPS. I'll give it back to Carl now. Thank you.
Okay, thanks, Lindsay. So we're going to transfer this now over to John Petter. So we talked in the previous presentations a little bit about identifying and aggregating data to find hotspots and clusters. We're going to get a little bit more tactical now, because at some point in time there's a specific location or a specific address or residence or business that's a problem, and John's going to talk about drone to map and some tactical collections on how you might be able to use this near real-time imagery collection to support for example, something like a drug raid. And then John and Rob, just for a time check, you guys each have about 7 minutes.
Okay, thank you, Carl. I'll move through this. So the application you're viewing on the screen right now is Esri's Drone to Map. The Drone to Map software is designed to take images gathered from drone flights and then mosaic those together into usable data sets. What you're seeing here on the screen is a drone flight that was flown at around 200 feet. The sort of orange line there is the path that the drone flew, and each of the blue dots represents one of the images taken from the drone. So this was flown at 200 feet, and you can see that the resolution of this imagery is quite extraordinary, considering that this drone flight just took minutes to fly, and then the processing of this only took about 30 minutes on my laptop. I can turn off some of these layers here on the left so I can actually see the resulting mosaic image, and I'll actually change the base map to light gray so you can more easily see the area of interest. So it took about 130 pictures in total, and it's mosaic them all together into now a product that I can use for planning and operations right over any house or area of interest. The imagery is actually so good you can pretty much see the tile patterns here around the pool and around the house. This is very easily collected and processed in Drone2Map. There's a lot of features in Drone2Map, including area measurements, distant measurements, volumes, and other tools in here. But in the interest of time, I'm actually going to show you something that's not just a 2D, but also a 3D. I'll switch products here into a different project. And I did another flight to produce a 3D model recently. Again, you have the same view here of the dots being each of the images that was taken and the flight path. The thing here is you can turn this now on its side and actually see where the drone flew. So this is, again, I've got a 200 feet, 150 feet, and a 50 foot, pretty covert from a drone. It's quiet. The whole flight took 9 minutes in total here. And if I turn off some of the layers so you can better see the image, you can see the accuracy of the imagery that we actually got from this quick drone flight. I can zoom into this property and actually look around the property as I'm doing a plan, maybe to insert folks into this property safely. I can understand the obstacles, where tactical advantage points might be, lines of sight, all those pieces just from a quick model put together in Drone2Map. The Drone2Map product is very easy to use. Once you've gathered the flight data, it's just a case of dropping it into the Drone2Map product, setting a few parameters, and pressing the go button. The products that come from these are not just a pretty picture. You actually get a point cloud as well, which you can use for analysis. And of course, you can bring all the products which are created in Drone2Map into Esri's sort of suite. So if I come over here and I'll show you ArcGIS Pro. So this is that same scene in ArcGIS Pro, and again, it's that same 3D scene. But now we might want to do some measurements and take some measurements here and understand what's the distance from the door to the road. So if we're sort of doing some tactical planning, some operational planning, and I want to know the size of the building, distance to the road, the length of distance that people might be exposed, we can do some view shed analysis here and understand lines of sight as well. There's also in here a point cloud as well. So this is the actual point cloud, which is derived from exactly the same product. When you run the Drone2Map, in the products folder right here, here's a series of products created from that, and I've got my 3D mesh, and I have my last file. I can use other Esri products such as ArcGIS Earth, and simply take one of those and drop it into here. So if now I'm doing some planning and I'm doing a briefing on this, we want to discuss this building, how we're going to approach it, who's got what assignments, I can just bring it into Earth very easily in my desktop, and now we can brief right on this, the full 3D scene of the facility that we might be working with. So Drone2Map is a very powerful piece of software and producing multiple products. Out of the 2D, you even get a digital surface model and a terrain model and a hillshade. And then on the 3D side of it, we've got a last file that's produced and a mesh. This can also now be published up to your portal or online. So now it can be part of your briefing. You could drop that into a story map or other information products to make all this operationally available. One thing of note on this one, it's quite amazing the level of detail. I found that there's a set of car wheels right here on the back of the building, and you can even see the lug nuts right inside that. So at 200 feet, we were getting 1/4 of an inch per pixel resolution. In the interest of time, Carl, I think I'll now just toss it back to you.
Okay, and we're going to push this over to Rob Fairstein, and he's going to kind of finish off the tail end of this tactical enforcement thread that we're going through here. And Rob, take it away.
Thank you, Carl. So again, we're going to use another template offered by Solutions. This is, again, another open source offering. So searching for the tactical operation solution, we can see it here. Again, we can go to the website, get more information on it, see what it's about. We can also get a live version of it if you want to play around with it and get a feel for it before you start utilizing it in your organization. One of the things that's required to deploy this solution is the solution deployment tool in Pro. So after you do a quick download and install it, you get this add-in within your Pro environment that opens up tasks that allows you to search for and deploy and then configure different solution offerings. So, and just to save a little time, I've already done that and deployed the tactical operation planning template to my ArcGIS Online organizational account. Once that's deployed, I have the feature service and the web map and the application needed. And what does that application look like? Well, that application comes with a pre-configured and easily adaptable feature service that allows you to take different notes for your tactical operation. It also integrates well if you have units in the field, either prior to the operation or during, that are conducting surveillance or pre-operational planning using Esri's mobile solutions such as Collector or Explorer. And then once you're ready to begin planning your tactical operation, there are several features that have been designed to help you with that. Before I do that, let me go ahead and leverage John's good work with Drone to Map and pull in some better imagery over this area. And zoom in a little bit. And so we can easily come in here and find different features, like for tactical units and the different teams involved for the plan, and begin placing them in their designated areas or their responsibilities for the operation. On the map, you can put comments in here, maybe the commander of that particular team. And we'll fill this out real quick. We'll throw another team in here. And we can also have other resources such as sniper. Maybe you need to place additional police vehicles at the end of the road for security purposes. And so forth. Like we said, so surveillance. You could also do your ingress and egress routes from your staging locations, as well as the different zones for your operation. Setting the perimeter. And once this is done, this can be, because it's in a web map behind the scenes, it can easily be embedded into a story map for pre-brief or for the after-action review once the operation is concluded, and then eventually for training purposes if needed. But that's a quick and easy way to use the web for planning your tactical operations. And with that, I'll hand it back over to Carl.
Okay, great. Thank you, Rob. We have just a couple minutes for questions, and I've got one. Rob, I think this one is probably best for you. For the tools and templates that you showed, I think the question is, are they 100% out of the box COTS?
Yes, they are. We've configured them solutions as so that they're easier for you to use. There's documentation to help you get up and running, as well as the sample data sets and tutorials to make sure you have what you need to understand the capabilities of the tools. And if you have any problems, they're fully supported by support.
Okay. Kevin Armstrong, just a general comment on insights or question on insights. For somebody that knows their way around a keyboard, an entry level knowledge of ArcGIS, what is the startup time? I'm trying to understand how to use Insights. What's your best estimate there?
Insights really is an interactive kind of drag and drop web application, so significantly less of a learning curve than trying to use desktop GIS. And some of the most commonly used tools in desktop GIS, like doing a spatial join or a filter, by attributes or location or density analysis are all part of insights built into it. So, within a day or two, you can easily have somebody up and running in insights, and really within what I showed is really just a matter of maybe an hour or two of sitting down next to someone and just showing them the basic functionality.
Okay, great, thank you. And one of the important things there too, especially with some analytical units, at least on the law enforcement side, young employees getting promoted, turning over, going to other places is sometimes, unfortunately, a pretty common thing. So the ability, on the back side of this, you obviously have to have people that are knowing what they're doing, and they, that could come from a centralized IT division or something like that. But the ability to be able to spend limited resources on getting somebody up and running on something like Insights, and the ability to leverage every other piece of data and technology within your IT or GIS infrastructure is really, really powerful. So the turnover certainly will not hurt like it used to in the past. And I think we have time for one final question, and I think this goes back to Rob Fairstein. A caller wanted information on the U.S. National Grid and where they can get a copy of that file.
So NGA, you can go to their website and get U.S. National Grid. There's also some available on ArcGIS Online. And also some cities or municipalities have that available in their open data portals underneath a 1,000-meter grid if that's what's needed.
All right, perfect. I have 10 o'clock on my clock here, West Coast time. That's going to be it for the day. There, you have the option to send us more questions through the webinar tool. My email is listed here, cwalter@esri.com. Happy to answer or talk to anybody that has additional questions. And we're going to close down. I appreciate and want to thank everybody for their time, and have a great day.